Hi, welcome back or welcome to Super Simple Dosage Calculation. I'm Nurse Jill, and I'm here to hopefully make your life a lot easier while you're in nursing school, medical school, veterinary school, or anything that you need to use dosage calculation in. I had a question come in from one of our viewers wanting to know if I could go over a couple of questions that address distractors. So that's what our content today is going to be on, and they are lurking in your dosage calculation questions. So let's get started.
Ladies and gentlemen.
So the first question that we're going to look at today is this one. As you can see, there's several components in this question. There's a three factor, there's several different labels with numbers. So let's read this and identify first what the question is asking us. Calculate the micrograms per minute flow rate for a dose of medicine at 6 micrograms per kilogram per minute that was ordered using a 300 microgram, 250 ml solution strength to be administered every 6 hours. The patient weighs 33 pounds, round to the nearest tenth. So some questions have what they're actually asking you towards the end, but this one we can see is different. It has the word calculate at the beginning, so we know that that is where the labels are that we actually want to set our equation up with. And just like always, we always set whatever we're looking for up to the left of the equal sign. And we go through the pattern of matching the first numerator to the left of the equal sign, to the first numerator label to the right of the equal sign. So I'm going to put this micrograms over minute equals because that is what we're actually looking for. So the first thing I want to do is identify what's in micrograms. So we have 6 micrograms and we also have 300 micrograms. Now, if you remember from past videos, or if you're a student who's been in my sessions, then you know that if we're looking for micrograms as our first numerator label, then we can only have one of that kind in our equation. So I call that my rainbow method. Each end of the rainbow has to match. There can never be less and there can never be more of the label that you're looking for in the numerator. So I know that one of these is what we're going to call a distractor. Now, for real life purposes, things like this do matter. For dosage calculation, though, I want to focus on the numbers and the labels. So if I used 300 micrograms, I would have to attach that to 250 milliliters because my rules say that I want to keep things attached together in my equation that are attached together in my question. And when we have a fraction bar, that's the same as the word per, and I call those my twins that can't be separated. So I can flip them upside down, which for this case, since I'm looking for micrograms, I'm going to keep microgram as my numerator label, but I can't separate those. If I use that, I would have a multiplication sign next. And my other rule says that if you end with milliliter, then the next numerator label has to also be a milliliter. So there's two of every kind in between, like Noah's Ark. So we look back through this question, there's nothing else in milliliter, right? So that's the first thing you want to do is see if you can find something else in milliliter or liter or microliter, something that you can convert. There's no other fluid component. So because I have to use both aspects, because they're attached with a fraction bar in my question, then I know that this is the distractor and I'm not going to use it. So I go to the other microgram. So the other is 6 micrograms and it's per kilogram per minute. So take them in order and do them one at a time. So 6 micrograms is attached to kg next, and we know that we put a 1 if there's no number. And then we know that the next label we have to put is also going to have to be in kg. Well, we look for another weight component in our question, and we have that the patient weighs 33 pounds. So if you want to do your conversion separately and say 33 divided by 2.2, you can certainly do that. For simplicity's sake, I am just going to put that conversion in my equation, and we're going to say 1 kg is equivalent to 2.2 pounds. Next, I know I've ended with pounds, so I can use pounds up here on top. So I have 33 pounds, and then I bounce right back to that 3-factor label and I pick up the 1 minute that I left off. See, because we have microgram slash kilogram slash minute, I need to use every part of that 3-factor label. The only reason I separate them for a moment is because I have to convert the weight. And then I go right back and I pick up that 1 minute. Now we've ended with minute, which is the denominator label that we're looking for. And we know that our upside down rainbow has to match. So just like the numerator that you start with can only have one of that label, the denominator that you end with can also only have one of that label. And so we know everything in between has 2 of every kind, and it goes bottom matches the next top, bottom matches the next top. And then we are ready to plug this in our calculator. And if you're using a basic calculator, as I am, and like you usually have to do in nursing or medical school, you probably come up with 89 point lots and lots of nines. So it says to round it to the nearest tenth. Well, I can't round it to 89.9 because there's infinity of nines basically, right? And we know if we got around to the 10th, that means we have to look at the hundredths place and we have to determine if it's 5 or greater, do we round up? Or if it's less than 5, do we round down? So since we have all these nines, that's actually going to round this up to 90. And we're going to put 90 micrograms slash minute. Now, I don't want to put 90.0 micrograms per minute because in medication administration, this is going to be considered an inaccuracy to put a trailing zero. It's always correct to put a leading zero if I have a number that's less than 1, but it's never the right choice to put a trailing zero unless your professor specifically tells you they wanted that method, which I doubt they will. So instead of rounding to the 10th, I'm actually going to keep this as the whole number of 90 micrograms per minute. So going back to the distractor aspect, and we're calling it that just because we want to get used to the way questions are set up and we want to get very proficient with doing dosage calculation to the point that we're not having to think about it too much. We know what we're going to actually go through to get to where we need to go. So the distractor of the 300 micrograms per 250 ml, we know is not what we're going to use because we couldn't match the ml to another ml or another liter or microliter. There's nothing we could convert it to. There's no more fluid components. So that's the first thing that you're going to look for. Is there something I can match it to? If you can't, then look at what else is there. Well, we know that we can use the 6 micrograms because we've got a kg, we have a patient's weight, and we have a minute. Now, did you catch the other distractor that's in this question? So do you see the Q6 hours there? That could be another distractor if you let it be, because if you incorporate the every 6 hours into this, you need to find out actually how many micrograms they're going to get per day. So this only wants to know the micrograms per minute. So the here and now, how many micrograms am I going to give my patient per minute? Not how many micrograms am I going to give my patient over the span of a whole day. So that Q6 hours, because we're not looking for day, is a distractor as well. Let's take a look at another one. Okay, the next question we have erythromycin, 30 milligrams per kilogram per day, PO, in divided doses every 8 hours. The patient weighs 35 kilograms. The drug comes in an oral suspension containing 300 milligrams per ml. How many mLs will the patient receive per dose? And round to the nearest tenth. So first, we always identify what they're asking us. So how many milliliters will they receive per dose? So we have milliliters per dose equals. Now with our method, we know that we have to have milliliters to the right of the equation since we have milliliter labeled to the left, and we'll only have one of that kind. So when we look back at our question, we see that there's only 1 ml, right? And that ml is attached to 300 milligrams by the fraction bar. So if those are attached together, we have to keep them attached together in our equation. But we can flip them to make them match. So the ml doesn't have a number, so we just put 1, and then we put 300 milligrams on bottom. Next, we know we've got to have another milligram label. All right, so we look at the 3 factor because that's the only one that has milligram in it, right? Once you break into that 3 factor component, which by that I mean milligram per kilogram per day, you need to use every part of that component. And again, we want to keep things as close together as possible in our equation if they're close together in our question. And just like the 300 milligram slash ml is a twin that we can't separate, but we can flip, the the 30 milligram per kilogram per day is a triplet that I also don't want to separate, but I might have to deviate to the side for a moment to pick up the weight. So just a few silly kind of things to help us remember, and it will work. All right, so we're looking for milligram. We have 30. It's attached to the kg next, and it doesn't have a number, so I put 1. Next, I look for the patient's weight. It's already in kg, so no conversion is needed here. So we have 35 kg. And next, we bounce right back to that 3 factor. So we've used the milligram, we've used the kilogram, and now we've got to use the day, right? Doesn't have a number, so we put over 1 day. Well, the question is asking us per dose. So we're not going to end with day because there's a time component in our question. So we have the Q8 hours. So even though they get this much per day, we know we're going to have to break that up into per dose. There's a few ways you could do this, but I'm going to keep it simple and I'm going to go by what's in my question. If it's in hours, I'm going to go with my hours component. So I'm going to use a conversion and I'm going to say 1 day has 24 hours. And then I'm going to do one more. I'm going to go down here at the bottom and I'm going to put times every 8 hours they receive 1 dose. See, because we have hours on bottom and we're matching hours for the next top label or the numerator label. So long equation, but you're going with the matching thing because it will work each time as long as you follow the rules. So we have milliliter for the numerator label we're looking for. We have dose for the denominator label that we're looking for. We have milligrams on bottom, milligrams on top, kg, kg, day, day, hours, and hours. And so we know that we've set this up correctly. So we're going to put this in our calculator, and it may take a second to plug all these numbers in. Make sure if you're on a test that you run this through a time or two just to make sure you get the correct answer as well. All right, so it says round to the nearest tenth. If you're using a basic calculator, you'll get 1.1, lots of sixes, and then you end in 544 usually. All right, so if I round it to the tenth, and I've got all these sixes, I know the one's in the tenths place, so I look at the hundredth and it's above 5. So I know this is going to round to 1.2 mLs per dose. So an example of a 3 factor. Now, a distractor in this that you could accidentally get confused by is the divided doses concept. So even though you're giving this in divided doses every 8 hours, You're not dividing that 8 hours and you're not dividing anything about this dose that you get at the end because it's already been worked out for you with this equation and the method that we're using. I hope that helps with the distractor concept. Make sure and check out my book, Nurse Jill's Super Simple Dosage Calculation. It's available on Amazon. I also recently released an ebook with over 400 practice questions on there too. And it's just called Super Simple Dosage Calculation Practice Workbook. Please like, subscribe, comment, and share. I appreciate you all. I love my students very much. Have a great day. Bye.